question concerns whether a neutral conductor in a 1600 amps, 277 volts, 480 volt service is considered a current carrying conductor for ampacity adjustment purposes. This scenario involves a 200 amps lighting panel supplying nonlinear loads. To determine if the neutral is a current carrying conductor requires careful consideration of the National Electrical Code, specifically sections 310.15 subsection B, paragraph 2, subparagraph A, and 310.15 subsection B, paragraph 4, subparagraph C. The crux of the issue is whether the nonlinear load constitutes a major portion of the overall load on the service. If the 200 amps lighting panel is the only line to neutral load, and it consists entirely of nonlinear loads, then the neutral conductor will carry significant harmonic currents. These harmonic currents, primarily the third harmonic and its multiples, add arithmetically in the neutral, potentially exceeding the current in the phase conductors. This increased current generates heat. Because this neutral conductor is serving only a 200 amp lighting panel that supplies nonlinear loads, we have to make the consideration that the amount of current that the neutral carries may be significant. This is irrespective of the mains size. While a 1600 amp service suggests a large overall capacity, the loading on the neutral specifically determines its status as a current carrying conductor requiring ampacity adjustment. If the 200 amps of nonlinear load represents the entire load on the neutral, then the neutral conductor must be treated as a current carrying conductor because it will be carrying a significant portion of the current due to the nonlinear loads. The key factor isn't the percentage of the 1600 amps main that the 200 amps represents, but rather the current flowing in the neutral itself. The neutral conductor's ampacity must be adjusted to account for the heat generated by the harmonic currents. A conductor that is sized 4 times smaller than the main service and is 100% loaded with nonlinear loads will still produce significant heat, requiring appropriate ampacity adjustments to prevent overheating and potential failure. Determining whether a neutral conductor is considered a current carrying conductor for ampacity adjustment requires a comprehensive analysis. This analysis includes 1. The size of the main service, 2. The nature and magnitude of all loads connected to the service, distinguishing between linear and nonlinear loads. 3. The harmonic content generated by the nonlinear loads. Without a complete picture of these factors, a definitive determination is impossible. If nonlinear loads constitute a major portion of the neutral current, the neutral must be treated as a current carrying conductor, regardless of the overall service size.